I don't have anything against consoles. They're a great value, and I own a PS5 and Xbox Series X myself. But what if you want an overpowered PC and access to your entire Steam library from the couch with a system that fits and looks like it belongs in the living room? So that's what we're gonna build today. Let's talk about the parts, put this thing together, then we can check out the thermal and gaming performance you can expect in such a small, compact system. For the CPU, I'm going to be using the 7800X3D. Now, there's a few reasons I chose this one. First, it's already considered the best gaming CPU you can buy, and that's in large part due to the cores being accelerated with 3D V-Cache, which gives them more performance in single-thread applications like gaming. The second reason is that it's very efficient, making it much easier to cool, which is going to be important for this smaller form factor where we can only fit a low-profile CPU cooler. The 7800X3D is currently priced at $450 and has 8 cores, 16 threads, and a boost clock up to 5 GHz. This CPU also requires a new AM5 motherboard. I'm going to be using the Asus ROG Strix B650EI. This has plenty of USB ports, including a couple of Type-C ports, and a load of other features like a BIOS flashback button. We've also got Wi-Fi 6E, a Type-C header, which we will need for the case that we're using, and 2 M.2 slots along with some giant VRM heatsinks. This motherboard does support the next generation PCIe 5.0 M.2 drives. Those aren't widely available right now, so I'll be using a Gen 4 Samsung 980 Pro. Gen 5 doesn't seem to offer any real benefits over a Gen 4 drive for gaming as of right now, so this will work out great in this build. I have a 2TB stick here, which is plenty of storage for me, but it'll be easy to expand with that second slot if it's ever needed. Okay, so now we can install the RAM, and for this build, we're gonna need DDR5 memory. So I'm going with 32 gigs of Corsair's Vengeance DDR5 5600 memory. We need to use lower clearance sticks here in order to fit our low profile CPU cooler. This isn't necessarily the fastest DDR5 memory either. AMD has commented that DDR5 6000 is the optimal speed for the 7000 series CPUs. Still, this should work out just fine for our build. Now we need to make sure that the notch is correctly aligned and then apply even pressure until you hear it click into place. Now we can install the CPU cooler, and I'm going with the Noctua NH-L12S. These coolers are pretty popular for ITX builds, as they have a low profile, and they do an excellent job keeping things cool despite its size. The total clearance on this cooler is 70mm when you have the 120mm fan installed underneath the fin stack, which is the exact max height we will be able to fit in the case. To install, we'll need to remove the pre-installed mounts from the motherboard by unscrewing these 4 screws and then taking them off. The cooler uses the existing backplate, so we can leave that in place and grab the 2 brackets that work for our chosen orientation. Now we can screw the new brackets into place and apply some thermal paste. A pea-sized amount in the center will work perfect. Next, lower the CPU cooler onto the brackets and begin screwing the cooler into place. Noctua actually includes a long screwdriver in the box to reach through these fins, which is actually really convenient here. We'll want to switch sides every 2 to 3 rotations to ensure even pressure across the CPU until it's fully into place. Now there's no need to use excessive force here, you can easily feel when it's completely tightened. Then we can plug in the CPU fan, and that's the motherboard prepped, and it's looking really good in my opinion. Super compact, and the CPU cooler is fitting perfectly. It's just barely clearing the VRM heatsinks, and it clears the RAM. Really good use of this limited space. Okay, so the case we're gonna be using is the Fractal Design Ridge. Now, I've wanted to build in this case for a while now, but they've been a bit hard to find. Although now they seem to be a little bit more readily available. There was an issue with the included GPU riser. It was originally marketed as a Gen 4, however, there seems to be some compatibility issues, so now they're only considered Gen 3 compatible. I'm not sure if they plan to fix this or sell an updated adapter. Still, it shouldn't affect our performance in any significant way. Of course, we need to remove the side panels, and to make the case easier to work in, I'm gonna unscrew and remove the top and bottom panels. Then remove the middle GPU bracket here, which also contains part of the GPU riser. So now we can take the motherboard, align it with the 4 standoffs, then use the screws included with the case to secure it. Now before we install the power supply, I'm going to plug in these case cables while I still have some room. So that's the HD audio connector on the top right here, then the USB 3.0, USB Type-C, and the front panel connectors on the left. Fractal gave way too much slack to the stiff USB 3.0 cable, so we're gonna have to figure out how we're gonna manage that. Now it's time for the power supply, and I'm gonna be using the Cooler Master V850 80 Plus Gold SFX power supply. Now you could get away with a lower wattage power supply here, depending on the GPU of course, but this is just what I had on hand, and this would leave a lot of headroom for a more powerful GPU in the future. So now we will need to remove this power supply bracket from the case by unscrewing on the front and back side of the case. And from there, we can slide the bracket onto the power supply and secure it with the included 4 screws. Now we can slide it with the attached bracket back into place and resecure it. Next, we can plug in the 24-pin motherboard cable, and it's located on the left side, which is pretty difficult to access now that we have the power supply in. If you are building this, it might be easier to also plug this cable in before securing the power supply. Luckily, I can still manage to get it plugged in without removing anything. Now we can plug in the 8-pin CPU connector at the bottom right and then feed that cable across the bottom and up the left side of the motherboard to plug into the power supply. I'm also going to plug in an 8-pin PCIe power cable that we will use later for the GPU and run that up to the top of the case. Finally, it's time to plug in the case fans by running them around the back side of the case and through one of the pass-throughs to the motherboard. Now let's install the GPU bracket. So we can open up the PCIe slot on the motherboard, then align the pins on the bracket to the PCIe slot and gently push until it clicks into place. Then just secure the bracket back to the case. And everything's looking great, so it's time to do some cable management to clean things up before we move to the GPU. For the GPU, I wanted to test out the newly released RTX 4070 Founders Edition. So first off, this card looks great. It follows the same design patterns as the larger 4080 and 4090s. It hasn't exactly had the warmest reception from initial reviews, which seems mostly due to its price to performance. Now, usually the 70 series GPUs offers the performance of the top tier card of the previous generation, but for like half the price. Instead, we're getting roughly 3080 performance for $600. And Nvidia seems to be leaning more toward the technology advancements and things like DLSS as the main value add more than just raw performance, which on one hand is fair, but the problem is not a lot of games use DLSS 3 and frame generation at the moment. And for competitive players, that's not really a technology they would utilize due to the increase in latency. In my opinion, that doesn't make this a bad card. Even at the $600 price point, it still might even be the best option for a lot of people. And with the 4070, you're getting the benefits of better ray tracing performance and DLSS in the supported games. Either way, I wanted to check this card out for myself, and I knew it would fit nicely in this build. So to get the GPU into the case, we need to remove this top bracket. There are 4 screws on the front side and another 8 screws on the back side to get this off. 4 of those are the top fan screws, which is kind of crazy in my opinion. I think Fractal needs to look into making more of this case toolless. Once removed, we can add the GPU riser to the 4070, align it to the slot on the GPU bracket, and gently push until it locks into place. Then plug the included power adapter into the 2 8-pins we ran earlier and connect the other end to the GPU. There's plenty of space for a larger GPU here. You could fit a GPU up to 335 millimeters, which should comfortably fit a 4070 Ti or even a Founders 4080. If you go for a larger GPU, you will want to be mindful of the clearance at the top for the adapter. You would likely need to get a right angle adapter or a cable that is more flexible than the adapter that's included with the 4000 series cards. Okay, now we can resecure the panels, and that's the build complete. Before we move on, if you want to see more builds like this in the future, it would mean a lot to me if you subscribed. It really helps the channel, and it's the biggest indicator to me that I should continue making videos like this. So thank you. All right, I think this build is looking really nice. And a few things I did to make it more console-like is to set auto login and then launch Steam Big Picture mode. But also, I wanted to be able to wake the system with a controller. Now, I found that this only works with the older Xbox dongle. I haven't found a way for it to work with Bluetooth or the newer Xbox and PlayStation dongles. If you know of a way, please let me know. Also, there's still situations when you'll need to update drivers or do other things on the PC. I use this mini keyboard I found on Amazon for $30. It's made using a living room PC, significantly less cumbersome. It has a full keyboard, a trackpad in the middle, and shoulder buttons for left and right mouse clicks. What's nice about this one is that it has Bluetooth and USB options. You can wake the PC by toggling the switch on the mini keyboard. It's pretty convenient. Okay, so now let's check out performance. Starting with Cyberpunk in 1440p and just rasterization, so that's without DLSS, and we're getting 60 to 70 frames per second. Realistically, I think in a game like this, you'll want to turn on DLSS and frame generation, and if you do, then you get a nice bump to around 100 to 130 frames per second. Now, if you're hooking this up to a 4K display with the same settings, then you're looking at around 70 to 80 frames per second. Now, frame generation will add a bit of latency, but I think that's fine for these more cinematic titles, especially considering it can nearly double the frame rate in some games. Jumping into Hogwarts Legacy here in 1440p, and rasterization performance is pretty decent at 60 to 70 frames per second on ultra settings. Now again, you can utilize DLSS and frame generation to get a nice increase in frame rate, and using those features in 4K, we're looking at 70 to 80 frames per second. And look at those temps, very reasonable in such a small form factor. Apex Legends again in 1440p high settings, and we're getting really decent performance here at 170 to 200 frames per second. And if you want to bump the resolution up to 4K, we're getting over 100 to 130 frames per second in those high settings, so you could drop those if you wanted more performance. For GPU thermals, running Heaven Benchmark, and it's averaging 64 degrees Celsius with very little fan noise. And in a worst case scenario, running a multi-core stress test in Cinebench R23, and CPU temps are reaching around 80 degrees Celsius. Considering the size of this low profile cooler, I'm still really impressed on how well it's cooling the 7800X 3D. Now this system is built for gaming, and those thermals look great in my opinion. I'm seeing the CPU and GPU averaging around high 50s to mid 60s depending on the game. So I'm quite happy with this build overall. I wish the 4070 had a more reasonable price to performance, but that's kind of been the story with most of this generation of GPUs. And I'm continuously impressed on how efficient and easy to cool the 7800X 3D is. That CPU is just a monster. And I think the case looks really clean as well. I didn't really run into any issues building in it, but I do wish Fractal would make some of it toolless. This is also a case you'll want to properly plan out ahead of time, as it's pretty limited in what it can fit. But I'm overall pretty happy with all the parts that I chose here. Everything ended up fitting together really nicely, and I didn't really have any issues putting it all together. Anyway, let me know what you think of the build. What do you like? What would you change? And if you want to build something similar to this, I'll have links in the video description. So thanks again for watching. I will see you in the next one.